I think, as far as I'm aware, the largest scientific non-governmental organization in the world. But it's not very clear at the moment where organizations like WDS will fit into this. We're an interdisciplinary body. ISSC did not have an equivalent, and there's still it's not clear at the moment how organizations like WDS will fit in. And part of the reason for that is that the ISC is still working out its strategy. It's still working out what it wants to do. But it's put out a public document late last year that at least identified some strategic challenge domains, and you'll see that the digital revolution is one of those. So, yeah. And the evolution of science and science systems. So these are important things where WDS probably has a role. And so again, I'm here to find out what inputs, guidance, support WDS can give to the UN Decade of the Ocean. And thank you. And there's an advert for our Asia Oceania conference, which will be held in May this year. Thank you very much.
Thanks very much, Roy. I think most people in the room are familiar with WDS, but you've made some nice upgrades over the last few years, so it was very nice to get an update. Thank you. Next up, we have Tim Boyer again, who's still at what I will always call the National Oceanographic Data Center of the United States. And so Tim's next talk is going to be on the World Ocean Database.
Hello again. I'm here this time to talk about the World Ocean Database and how it can facilitate the understanding of ocean climate for the UN Decade of the Ocean. These are my co-authors, including Hernan Garcia, who's here, who's part of the World Ocean Database, but also a partner as the director of the World Data Center for Oceanography, World Data Service, excuse me. And this project, the World Ocean Database, was started by Sid Levitas in the 1990s. So here's this picture again from the United Nations Decade of the Ocean. And again, just to emphasize the idea of gathering ocean stakeholders worldwide behind a common framework that will ensure ocean science can fully support countries in creating improved conditions for sustainable development of the ocean. And we'll look at a little different aspect of that now, kind of the big picture of how the data can come together and be used for some aspects of understanding the ocean and to the benefit of society. And this is a big picture, very big picture, investigating the scientific problem and societal solutions. We're going to look at the Earth's energy imbalance. So this is from the IPCC, the Intergovernmental Panel on Climate Change report in 2013. And it's a diagram of the Earth's energy system. And the units are watts per meter squared, and the incoming solar radiation is in yellow on the left there, and on the right is the outgoing or not outgoing long wave radiation. And the part of great interest, these are some really big numbers, 340 watts per meter squared, big number, and going out 239 and so on, is in that red circle there, the 0.6. Relatively very small amount, 0.6 watts per meter squared, which is the imbalance. That which is the outgoing does not balance the incoming. So that's the part of great interest, because that is that which stays in and affects the Earth system. And this is again a figure from the IPCC, and it shows on the y-axis are zetajoules, 10 to the 21st joules, and on the x-axis is years from 1970. And the blue part there is the contribution to the excess heat in the Earth system from the ocean, the light blue from the upper ocean, dark blue from the deep ocean. Then you also see contributions from ice, land, and atmosphere, which are those very small parts at the bottom there. So it is, what we experience is basically the atmosphere. But if you want to understand the climate system and how much the the Earth is sequestering heat, you have to understand how much heat is going into the ocean. And so how do we do that? And I should say we don't, to understand into the UN Decade of the Ocean, into the future, we have to understand how the Earth has been changing at the present and into the past. So what we need is a data set for the subsurface ocean profile data. And this is a diagram. This is years from 1900 to the present, and to 2018, actually not quite the present. And the number of oceanographic casts, sets of profiles that have been taken with all the different instrumentations. Black is the bottle data, and I'll speak about the other instruments on the next slide. But this just shows that before about 1950, there were very few data, mostly bottle data. And since then, the observing system has grown, and hence the number of observations. And gathering them together is important to be able to look at ocean heat content or other subsurface oceanographic changes. And these data are from the World Ocean Database. So the World Ocean Database is a heterogeneous aggregation of ocean profile data, because there's been a lot of instrumentations over time, and they take ocean profiles for a lot of different reasons, not particularly in the global sense. Often ocean expeditions are regional or basin-wide at the best. And so we need to gather the data from all these different cruises and projects, gather them together to get a full global picture. So we have the different types. You see the bottles, which have Nansen and then Niskin bottles since the late 1800s, early 1900s. The mechanical bathythermograph, which was the first to measure a continuous profile that began just before World War II. Then you have the expendable bathythermographs, which made it much easier to drop from a merchant ship, and those came in about 1967. The conductivity temperature depth, with the bottle rosette there you see, and those are basically the research grade temperature and salinity. Then you have some iterations on that, undulating ocean recorders, basically a CTD that undulates behind a ship. You have profiling floats, which is mainly now the Argo program, which are now autonomous floats. You don't need to send the ship out to continuously take information. You just drop a profiling float, and every 10 days it'll send its profile information to a satellite. You have moored buoys like the Tau array in the Pacific Ocean, Rama and Parada in the Indian and Atlantic across the tropics. You have drifting buoys, drifting ice buoys up in the Arctic right now, the Ice Tethered Profiling Program, which is built on, there was also the Japanese program, the JCAD. I can't remember what that stands for, I'm sorry. Then you also have other sources like instrumented pinnipeds, which basically is looking to find out biological information about habits of the pinnipeds, but they're taking temperature and salinity information to sometimes to depths deeper than 1,000 meters. You have gliders which are coming in, especially in more coastal regions. Then there are also surface data and plankton, which are not major parts of the World Ocean Database. Those are covered by other databases, but there are some of those data in there as well. So the variables in the World Ocean Database, I've talked basically about temperature so far, but there's a lot of other variables: salinity, oxygen, phosphate. So the nutrients, chlorophyll, there's the carbon cycle variables. There are tracers such as chlorofluorocarbons and tritium, helium. Basically anything that's measured from a bottle or some other type of instrumentation is in there. And this includes now the bioargo variables and the different instruments. I mentioned most of those. Well, I mentioned all of those already. So the blue, we don't have the expertise for all of these data, but we do for temperature, salinity, oxygen, and the nutrients. So those are that we give quality control beyond just the basic automatic checks. So when talking about delayed mode data, so a lot of data doesn't even go out over the GTS, although many of the data do go out. And the World Ocean Database now is updated every 3 months. It's updated, and we continuously are gathering data at different time scales. So quarterly we get data from ICES, I'm losing all my acronyms. International Council for the Exploration of the Seas, based in Copenhagen. CCHDO, the ice tethered buoys, and different. We get, and when I say we, at this point it's NCEI as a data center is getting some of these data, like from Canada or the Japanese Oceanographic Data Center on different times. INADEP in Argentina, different entities within NOAA. So any place that we can get these data, we gather it together into the World Ocean Database. And of course, we did talk already about the near real time from GTSPP and Argo and so on. So we bring all of that data together to get a historic up to the present time series to make these studies. So this is an example. We work with different entities in Brazil, the Brazilian Navy and the Brazilian government and institutions there, and have over the years gathered together Brazilian ocean profile data into the World Ocean Database. We have data from 1954 to the present, both CTD data, expendable bathythermographs, and moored buoys, because the Brazil's involved in the Parada array. So gathering these data together is all of these data, or most of these data, were taken pretty close to Brazil for specific monitoring of fisheries or to study physical phenomena in the Brazilian waters. But these information are extremely valuable on a global scale, especially here, especially into the tropical Pacific. Amazon outflow is very important, different things. So these contributions from Brazil, when they're put in a global database, can really enhance the global picture. But in reverse, there's a lot of data in the Atlantic that the Brazilians can then use back for their own regional needs to inform their studies and their decisions about Brazilian near coastal waters. So this is basically using a pooled data resource and something that can feed into the UN Decade of the Ocean, Decade for Science and Societal Enhancement. So as I just spoke about, institutional and national data centers are contributing to this global understanding by contributing into the World Ocean Database. Then those global data contributions contribute back to the regional and even local level for understanding as you get data from outside your own country's region, or inside your country's region for that matter, but taken by international ships. So when you go to the global ocean heat content, now we have this global picture. We can start to understand the rate of global warming, which is extremely important going into the future for mitigation, for understanding what we need to do to adapt or to hopefully try to slow that rate. Then other things like sea level change, steric sea level change, thermal expansion, haline contraction. These have global and regional implications. Ocean acidification, which was spoken about before. Freshwater inputs, which you can get from salinity. Deoxygenation. So as water gets warmer, it holds less oxygen. That has implications for the biology. And then these are ecosystem impacts. So the World Ocean Database and gathering this information together can help look at all these things on a global and then down into a regional scale. So the WD has a lot of project connections across IODE and out past IODE. So of course, World Ocean Database has been a IODE project since 2001. And at this point, we now have data mirrored from the World Ocean Database directly on the IODE server. GODAR, the Global Oceanographic Data Archaeology and Rescue, where we work with other countries, other institutes around the world to bring data that may be in paper form or in other types of magnetic tapes or something, get that into a digital form, get it into the World Ocean Database, and that's the conduit for GODAR. Global Temperature and Salinity Profile Project. So that is the near real-time data that is fed into the World Ocean Database. And not all that near real-time data is replaced later by delayed mode. So for a lot of the data we get from GTSPP, that is the record. We don't have anything else. As I spoke about before, the World Ocean Database is a CMOC in the Marine Climate Data System. And then there's the IQUAD program. I have a poster on that outside for the IQUAD community. That's International Quality Controlled Oceanographic Database. So it's one thing to get these data, heterogeneous data, into a database. It's another thing to make sure that historic data is all usable, even up to the present. So IQUAD is gathering experts from around the world to look at those data, even on a one-by-one profile basis, and make expert quality decisions. And that feeds back and is represented in the World Ocean Database. And we also have some connections which we'd like to develop more with OBIS to hopefully include profile data with that biological data within OBIS. So there's a lot of connections globally for the World Ocean Database that can enhance into the UN Decade of the Ocean. And of course, all the data that comes in, that goes into the World Ocean Database, is also kept in the archive at NCEI. So if you don't believe the World Ocean Database and the quality control, or think there might be something wrong there, you can always go back to that original data. So, I mean, I spoke about this as, I guess, kind of a wrap-up. Why use WD as a global tool for ocean profile data? Well, it's long-running, well-established data set. So we have a large oceanographic community that both for input data and that uses the data. This can avoid duplication of effort. Instead of different groups around the world gathering data for different parts, different regions, or so on, we can use, thank you, the World Ocean Database as a single repository, and then these regional and local experts can help do the quality control on a global scale, so that you only have to go one place to get the best quality data. Of course, it's quarterly updates for climate studies. That should be, I would think that's good enough. There's new data put in and improved versions of the historic data. So there's a large community that inputs the data, that uses the data on both sides, and which is not shy at all about telling us about the quality of the data. And so we get that feedback. We make changes in the database. We get improved data sets. So we're always updating and have what we hope is the best quality source for the global data set for ocean profile data. And as I mentioned, connections with the other international products. And I didn't speak about this. I wish I had put more in about this. But one of the big problems in the World Ocean Database, in any aggregated database, is the credit is not always apparent. Even though the institute, the project, and so on is with each, that metadata is with each ocean profile within the database, it's not always evident. So we're working on retaining DOIs that come, digital object identifiers that come with the data. So you can get back to that original source, you can know who it is, who has worked on it. And even more, we're working on something, this is from Guy Castigliao and at Scripps Institute, is working on this cascading DOIs. So not only do you know what project, what institute, but you can know who actually made the measurement, who did the initial quality control, and all of these type of information can be set up in a network of DOIs that you can get from the one DOI that you find within the data. So that's really important for getting credit back to those who have contributed to it. Thank you.
Thank you, Tim. Our penultimate talk in this session is from Professor Eduardo Klein from Intecmar. He's in the Department of Environmental Studies at Universidad Simón Bolívar in Venezuela.
Thank you. There you go. Okay. Yeah.
Seconds.
The bed. Okay.
Make it and wait.
Okay, thank you, Claudia. Thank you very much. I would like to about OBIS. OBIS has been mentioned during the day. And OBIS is the Ocean Biogeographic Information System. And I would like to talk about the possibilities of OBIS contributing to the UN Decade of the Ocean. So a brief history of OBIS. OBIS started in early in the year 2002 when it was designed as a repository for all the biodiversity data from the Census of Marine Life project. And this was the legacy, as Julian mentioned this morning, of the census after the census ends in 2010. In 2009, the project was adopted by the IOC UNESCO under the IODE program, and now we are operating since 2011 at Oostende after the project was moved from Rutgers University to Belgium. So OBIS is a database of it's actually much more than a database, but it's basically a database of marine biogeographic information. We actually hold more than 55 million records from almost 125,000 marine species from almost 3,000 different data sets coming from more than 800 institutions and provided all around the world by our network of more than 33 regional OBIS nodes. But OBIS is what we like to call an ecosystem that interacts from its core, which is composed by tools, training, programs, and data services, interacts with the partners, our users, and our nodes. And we also promote the interaction between the partners, users, and nodes. We understand that we have different kind of users, and we understand also that we have different kind of nodes that provide data services, and almost, not almost all, but some of them provide also training to the data providers all around the world. So speaking about the regional nodes, we have actually 32 regional nodes all around the world. And those nodes have the responsibility of collecting data, engaging with the data providers, performing quality control and quality assurance of the data that comes into the system and distribute in our portal. Also, always promotes very strongly the collaboration between scientists. So you can see how, for example, by now there are more than 1,000 papers citing always as a main data source from almost 3,000 scientists all around the world. And you can see how the connection between the different countries exists because of OBIS, that it's a catalyzing element between the scientists. And why we say that OBIS is a good database, a good system, because OBIS is based in the standards. So for the data collection and the data storage, we use Darwin Core, which is a standard schema for storing biodiversity data. And we also use another standard, which is the ecological metadata language, the EML, which is compatible with the ISO standards as well. And both are integrated into our system. We also have a very strong set of quality control procedures, almost 30 different quality control procedures that are applied to the data, from taxonomic quality control, geography checks, depth checks, completeness, data format. We have some required fields. And we also check for outliers, spatial and environmental outliers, and every single record in OBIS is flagged according to these quality control procedures we put on the data. So we have in the database represented almost all the spectrum of marine biodiversity, representing more or less the same proportion that you can find in the nature. For example, the green bar here is fishes, which are one of the most abundant groups in the ocean. So followed by gastropods, polychaete, etc., etc. And we have a lot of records coming after the census end by the 2000 and 2000. But we have a gap in the temporal coverage of the data. I will talk about this later. We also have some gaps in the spatial domain, and you can see this is a number of records, species, and sampling events, and you can see that most of the records come from the surface of the oceans, which is easy to sample, and also nearby the continent, so in the continental platform. So we have a gap in the middle of the ocean. So if you add everything together, you can say that 2/3 of our knowledge comes from the top layer of the ocean, which is more or less 5% of the volume of the ocean, which is not too much. As we talked this morning, and Julian presented about the decade of the ocean science for sustainable development, whose vision is to develop a scientific knowledge, build into infrastructure, and foster partnerships. They have envision some outcomes from this decade to transform the knowledge, to measure impacts, to reduce vulnerability, to bolster observing system, deliver data, and accelerate transfer of marine information and technology. So we think that OBIS can contribute to few of them, and I will go one by one, not all, but few of them. For example, delivering the best available knowledge for decision making. We have now a new version of our portal, OBIS 2.0, that has just been released, and there is demo if you are interested in look at that during the coffee breaks. You can go and see how it works. So it's very easy to search the information and to obtain information. And you, for example, can ask for all the biodiversity record existing in the Caribbean region. And you as a manager or as a scientist or as a decision maker, you can have all this information in one single place, and you can download the data with the metadata, and you can check the quality control, and you can have everything that we have in OBIS database just clicking the portal. So also, one of the things we have, which is make us very strong, is that we integrate the data. For example, if you look information for one particular species, Abra alba, which is a small bivalve shell that inhabits the eastern Atlantic Ocean and Mediterranean, and always has almost 50,000 occurrence records for this species. But that comes from more than 100 different data sets in the same place. So in OBIS, we are integrating data to facilitate the user to discover the information we have. So we think that with this particularity that we have, we also bolster the ocean observing system, data system, because if we provide the people a way to integrate the data with other databases, it's more easy to them, or it's more, I mean, it's easy to them to say, okay, I will collaborate with the system, because we are not, as I used to joke, normally we cannot put a gun in the head of the scientists or the monitoring managers to say, okay, you have to put the data into OBIS. No, it's not that way. We have to provide a system that is good for them. So they say, okay, we want to put the data because it's useful for us and useful for the users at the end. So we also foster the ocean observing system because we design different schemas for the data. For example, we have been working with this event core schema that allows us to incorporate environmental data and sampling description of the procedure, how the sample was collected, along with the biodiversity data. So, for example, with that, we can accommodate, for example, profile data with occurrence data easily, very easily, as long as we can handle standardized vocabularies right now. Also, we produce open access tool. So not only the portal, so it's very easy to use as a manager, but if you're a scientist with more capabilities of analyzing data, so we have some tools for you that you can interact very easy and programmatically with the database, so do more complex analysis just accessing the database we have. Also, we are promoting collaboration between different groups and different initiatives all around the world, and this is one case, for example, with the Marine Biodiversity Observation Network Pole-to-Pole project. This is from GEO Group in the Americas. And this is a project that deals with, it's a continuation of the Nagisa project, which was a project from the Science of Marine Life to study the rocky shore communities. And then we are involving people from pole to pole of the America, from Alaska to Antarctica, actually, passing through the Atlantic Ocean and through the Pacific Ocean, all around the Americas. And also incorporating oceanographic data, like, for example, these temperature loggers mimicking a limpet. It's called robo-limpets. So we incorporate the information about biodiversity with environmental data we are taking. So as you can see in the bottom right corner, so we are adding more and more papers into the mainstream of the publication using OBIS data. So we also can accelerate and transfer the marine knowledge to the people. So because we have a very strong, as I mentioned at the beginning, in our core ecosystem, a strong capacity development program, and we are using Ocean Teacher Global Academy as our main partner. So we have so far trained almost, I think it's almost 20% of all the participants of the Ocean Teacher Global Academy courses, about 300 people from 72 countries and doing more than 20 different courses on how to use OBIS, from the very basic things of how to format the data into Darwin Core to very complex things like how to develop tools for ocean tracking network and analyzing tracking information. Also, we promoted strategic alliances, and this is one case that we have an agreement with the Global Ocean Observing System, the Biology and Ecosystem Panel, with the Marine Biodiversity Observation Network and with OBIS. So GOOSE is providing the framework for the essential ocean variables for the biology and ecosystem system, equivalent to the physical and biogeochemical system, but for the biology. And MBON, the Marine Biodiversity Observation Network, is promoting the monitoring of those essential ocean variables using the essential biodiversity concept they manage. And OBIS is providing the data sharing, data quality, the data service, and the data training for all the group. Also, we are collaborating with many international processes, like, for example, different assessments, like the UN World Ocean Assessment, the IPBS. We are working very close with the Convention for Biological Diversity in its EBSA, ecological or biological significant areas in areas beyond national jurisdiction. Vulnerable marine ecosystem from the FAO, Deep Sea, GOOSE, as I mentioned, MBON, et cetera, et cetera. So we are participating in many international process. So finally, we have now, during this coming decade of the ocean, many opportunities. For example, we are looking at new technologies, new ways of collecting data, new ways of providing good quality data. We will have emerging partnerships. That's definitely the path we have to follow. And we will probably have mandate from multilateral organization, which is a big responsibility for OBIS. And we also have this essential ocean variable framework with these near real-time monitoring systems. But also the opportunities come with many challenges. For example, we have to agree that we have a delay in data availability. It's very difficult to say to scientists to deliver the data the same day they collect it. They want to keep the data for publication. So we have to deal with that. We have new data types, like, for example, environmental DNA, cytobots, images that can produce you thousands of records in a matter of minutes. We have taxonomic, temporal, and geographical gaps, as I mentioned. We have to maintain this partnership engagement, which is very difficult in the long term. And we also have many clients, which means that every client, every user has a different interest. So we have to deal with that. I would like to end with a quote from Edward Deming, which he was an engineer, North American engineer, and probably the first data scientist of this era. And he mentioned that without data, you are just another person with an opinion. And I would like to remind you that marine biodiversity data, I know you know already, is ocean data as well. Thank you very much.
Thank you, Eduardo, very much. I love that quote. I agree. So we're up to our final presentation in theme 5, and this will be given by Tosta Tanwa. Tosta is a chemical oceanographer at Guiomar at the Helmholtz Center for Ocean Research in Kiel, Germany, and he's going to be talking to us about the Global Ocean Observing System, the GOOSE 2030 strategy. Thank you, Tosta.
Can you just stand normally?
Yeah, okay.
Yeah.
And this is
Just,
So thank you,
Just-
Cindy,
yes.
for
Wait.
that introduction, and thank you for having me. And I know I am the last speaker of a long day after a long flight for many of you. So my name is Tosta Tanwa. I'm here as the co-chair of the Global Ocean Observing System. I'm basically going to talk to you about partnerships and about a strategy that we are launching now in GOOSE. You've seen a picture like this or similar of that. This is the networks from the Global Ocean Observing System. From the ECOMOPS, a very important tool in GOOSE. And this is another view of the Global Ocean Observing System, just describing that we are having a national and regional and basin scale observing system, as well as global observing system. And this is maybe the most important slide. Up to the left here, you see the framework of ocean observing. That is a document that was adopted by IOC as the framework guiding goose in 2012, coming up from the Ocean Ops conference in 2009. And the boxes here describe the process of ocean observing. So up to the right, you have the pink box that sets the requirements of observing. And why do we need to observe? What do we need to observe? Where and how well? And this is the requirement setting. We mentioned, the last speaker mentioned the essential ocean variables. That is happening in that box. And the small boxes inside of these boxes describes then the organization of goose. So we see in that requirement setting box, we had three panels of goose: the physics panel, OPC, the panels for biogeochemistry, IOCCP, and the bioeco panel that was just referred to by Udin. That feeds then into the more pinkish box to the bottom right, where we have the observing, the trading space for how do we do observations. And we see the link there to JCOM, what Nadia, for instance, was talking about in the JCOM ops, who represent the status of the observing system, the metadata service from JCOM ops, a very important part of knowing what the status is. And down to the observing networks. And these are the networks that actually are delivering the EUVs to the observing system. A little bit to the right there, we see the goose regional alliances that I showed on the slide just before, and a national system. So these are the deliverable or the observers that deliver the observations. To the left, the green arrow is what's really relevant for you all in this room and for this conference. This is the data and information. IODE and the WMO information system and others represented by these two bodies, I would say. Of course, there are a feedback loop from the information back to the requirement setting. Are we meeting the requirements by the information that we gathered? And an observing system as a whole is not complete unless you have filled all these boxes and the loop here. So I'm here to engage with IODE for the best or the benefit of the global ocean observing system. Down to the right here, you see some regional projects that kind of exercise most of the FOO in a regional way. So that's the Tropical Pacific Observing System, the Deep Ocean Observing System, Atlantis, which is the basin scale, and MESCAT, which is a sea level exercise in the Mediterranean. So in the goose strategy, we have a vision. This document is going to be released in a couple of weeks. We're going to have a slightly different wording of the vision, but it's basically saying it's partnership and participation for a fully integrated global ocean observing system, providing critical ocean information needed to address climate change, generate forecasts, protect ocean health, and support sustainable growth. That is the vision of the global ocean observing system that we need you to help deliver. We're looking at the ocean opportunities. The ocean is driving climate, very important in climate. We have food security. There are risks associated with the ocean. We have a fantastic discovery, particularly in the deep ocean. So many things we still don't know. We talked a little bit about the mandates, the sustainable development goals, and so on. I don't think I have to talk more about that. And I know you've been talking a lot about the ocean decade. Interesting enough, our vision and strategy is falling in the same time frame here as the ocean decade. The mission of GOOS is to lead the ocean observing community and create the partnerships to grow an integrated, responsive, and sustained global observing system. And no matter how you define GOOS, GOOS is just the sum of all the partners and the GOOS itself to move towards our vision and the mission. We need this partnership and we need to work together. GOOS is looking at basically 3 societally relevant areas to deliver. It's climate, operational services, and ocean health. And you could probably divide that a little bit differently and say that different, but that is one way that we think is useful to look at it. In the GOOS strategy, we are looking at 3 different main goals, and we have 11 strategic objectives. I'm going to go through them very quickly. Down to the left, we see the deepening engagement and impact. So we have strengthening of partnerships that we need for delivery. We need advocacy and communication of ocean observations. We need to evaluate the impact of the observing and the information. And we need to empower and innovate new innovation applications. And the top left, integration and delivery, that is kind of the core business. So it's about observing design, sustain and the observations, and very important, the open data principle. And we're building for the future. We support innovation. We want to guide capacity development, very important. Observe human impacts and champion effective governance. So I put here a short version of the IODE objectives. I know they are changing, but I try to distill them a little bit down here. And I put some arrows in there between the objectives of IODE and GOOS, and there are many interlinkages, particularly, of course, with open data and strengthen implementation in terms of best practices. That arrow is unfortunately missing on the slide. Partnerships, advocacy, so that is about applications, the end users' products, and it's about capacity development. So this is how I see that there are many interactions between GOOS and IODE that we can deepening and work out how we actually will engage with each other to deliver, because in the end it's about deliver to end user, whatever the end user is. This is the value chain of ocean observations. We start with observations. This is another way of looking at that full schedule. The data management, this is this group. Analysis, forecast, and models. So that is more down to a information to the users. Applications, even more downstream, and then the users itself. So in the GOOS strategy, we think that the FAIR data system is an important part of our mission. Without having definable, accessible, reusable, interoperable data, we will never reach where we are going. So that's one very important engagement point with this group, how we can improve that. Thinking particularly that many of the ocean observations that we have are driven by science projects rather than by operational services. And we are making progress in making that data more accessible, but we have quite a way to go. And it's also about making that data accessible over different, we heard a lot about that this afternoon, different ways that we can take the data in different formats and make that usable and accessible for the end user in many different ways. And that is one way of looking how that could look at. And this graph here shows that we are looking at very different scales. We have the coastal scale, very regional. We have areas like the Caribbean or the East Sea. We have the basin scale networks that's coming up, like Atlantis, and we have the global system. So, and these are delivering data at different scales, spatial, temporal scales, and we need to look at ways that we can integrate that seamlessly in time and space. Ocean Ops 19, that is coming up in September in Honolulu, very important, so I hope I see many of you there at a conference. So that is follow-up of the 2009 conference, which was in Venice. And we're looking at many different ways to engage end users and improving the framework. And one thing that we're looking particular at and what I would like to talk to you a little bit more about is the governance of this ocean observing system. So GOOS, which was mentioned before, started as a more physical and operational observing system. And since 2012, where we engaged in the full process, we are looking at biogeochemistry and biology in addition to physics, and thereby engaging many more end users, but also observing systems. And that leads, in the end, that we need to revise and improve our governance system of the whole thing. So we want to engage with IODE and the ocean data management community in this process. So I hope that you can engage and let me know what you think. We have a community white paper, and we're organizing a series of workshops. We're going to have a process in place to get feedback from the community. GOOS and IODE are already collaborating, of course. We want to deepen this collaboration. The fair data principle is a very important principle for GOOS. And I hope that IODE and WIS can be partner in delivering that. We're looking at deepening the partnership. And as I say, I think that we in GOOS and IODE can find ways to work together to improve the value chain from the observations all the way down to the end users. That's what it's really all about. And keeping the appropriate accuracy, quality, and latency of the data. Thank you.
Thank you, Tasta, very much. So Tasta finished in less than 15 minutes, which made the difference between us being able to have discussion or not. I had given up on discussion. Thank you very much. So if I could ask all of the speakers to come back up to the front. We do have 6 minutes, which... yeah, then Norio has to make an announcement. So we have about 6 minutes, and Sergey Belov has been asked to moderate this discussion. So I'll hand that over to you, Sergey.
Yes, thank you, Cindy. So on behalf of the conference, I want to thank all the speakers of this section. Yes, this was, they were lengthy, but very interesting and topical presentations. And yeah, I don't want to summarize nothing because I will give the floor to the room. And I'm just inviting the room for the questions and comments, please. Yes, please, Hernan. Can we give a mic, please? Yeah.
Well, first of all, thank you so much for the presentation, very informative. One item that I thought it would be, in my humble opinion, something that we could think about integrating here is what is the relevance of the information that we have through the observing system for delivering societal relevant decisions. What role the data have, for example, in the blue economy. These are things that, for example, the role of operational oceanography in creating, forecast systems which enhances the quality of life and the protection of property and things like that. I think this is something that I have not seen much discussed, but I think that will be important to incorporate, because this is what, in the eyes of certain communities, is what they see, is that we invest in something, but what do we get back? I'm a scientist and I totally agree with the data that we get, but we need to also speak to other communities.
Thank you, Hernan. Since the ocean observing system has been built by scientists for scientists by and large, we are serving that community well. We are not serving the other community, the maricultures, the local fishermen, the local communities very well. And I think the main problem is the accessibility of the data. So we have some good data integrators where if you're an expert, you can go and get the data. But that step in between NCEI, Copernicus, and so on, and the end user is largely missing. That, we all take our cell phone and look what the weather is going to be tomorrow. We don't have much of that in the ocean space. And I think that's something that we need to work on, delivering that information piece from our data. And so it's actually about accessibility of data, I think.
Just maybe on this, because I know that GOOS is also working a lot on showing the value actually of ocean observation for blue economy, and there's some new work done as well to enhance that, and also because it's in the end translating the data into information. And that's something where we need visualization, and this is also what we are planning, for example, with the data we are collecting for ocean acidification, making it relevant so that it's not only those data you see data points, but also that this is a tool you can then use for really changing and adapting and mitigating, because that's the further goal. And I know that Goose is working a lot on that, and we as well in the ocean science section are going into that direction. And in the end, this is what I always want to say as well, is that you see ocean science as an investment and not a cost, and we have to give a little bit proof for that.
Okay, thank you, Tosta. Thank you, Kirsten, for the clear answers. Do we have any other questions from the room, please? Any raised hands? Yes, I see one, two, please.
It's a very quick question for Rory, actually, and I'm sorry if I missed it. The Core Trust Seal certification, is it yet mandatory for your members?
Yes, for regular members. Yeah. Well, so any regular member that's renewing their membership, they will be required to go through the Core Trust Seal certification now. And the other thing that needs to be sort of emphasized with that is 2 points. One, there is an administrative fee, which is unfortunate, but is reality. I mean, to run a certification, it costs quite a lot of money, and it's still basically heavily subsidized by in-kind contributions from WDS and DANS in the Netherlands, but that's the one thing to remember. And the other thing to remember is it's now, so WDS had a 5-year renewal period. The data seal of approval had a 2-year renewal period. We've now made it 3. So WDS membership and Core Trust Seal certification are aligned at 3 years.
Okay. Okay, I've got the signal that this was the last question, unfortunately, so we have to be in time. And yeah, should I summarize something?
Sure.
Yeah, okay, just, give me a minute. So to summarize the topic of this 5th theme, that there is no doubt that assessing and streamlining the UN decade of the ocean science for sustainable development will be one of the priorities for the next 10 years, at least for IODE, right? And IODE is expected to make a significant reinforcement by supporting and developing its projects, existing and new ones, enhancing the role of sharing knowledge, data, and supportive information as well, and the services with key projects, programs, and initiatives, as we heard today. And considering the changing landscape, the WMO reform, JCOM, WDS, we have to consider is as an opportunity and also the challenge as well. And I would like to thank you, all the speakers and the session chair and those who raised the question. Thank you so much. We have to be precise like a Japanese trains. Thank you so much.
Thank you, Sergey. Thank you, everyone. Thank you to the audience for your attention today. Norio Baba, are you in the room? Don't go yet. We have one more announcement from Norio, who's planned a party for us.
Thank you for everybody, but good cooperation. First of all, we would like to express our appreciation to the interpreter. They had hard work, long days. Thank you very much. And another important news is, as a local host organization, we have a welcome reception at the next door. Start from 6 p.m. So international participants and all IOD session and the speakers are invited to the welcome reception. And during a reception, we are going to tidying up this room so that please bring your belongings to the reception room. There is enough space and a table to put your bags and coat, so that I request your cooperation. And tomorrow's session will start at 9:30 again. Yes, and registration counter will open 8:30, so please come before the 9:30. And please leave the receiver for interpreter on your table. Thank you very much.
Yeah, the conference. I'm gonna need. Can you read this?